I am Agendu. I am doing this BS degree as an ES student, and I am also an RC for Wayanad House from the Bangalore region. So today we will have a session for the revision for quiz 2. As you all know, the syllabus is week 5 to 8. So we can do it as a quick revision of the required formulas and details that you have to be prepared with for the quiz. And then if you all have any doubts, please feel free to interrupt anytime. So let's start. Sorry, am I not audible? Am I audible?
Yes,
Okay,
yes.
somebody was putting messages in the chat, so I hope it's their problem only. Okay, so I'll share my screen. Okay, so let's start. So we have the week 5 content. So for this session, for week 5 to 8, when we are focusing, in week 5, we have the derivatives and their applications. Mainly we are focusing on that. From that, we will continue to the how to find the derivative, the rules for differentiation, and certain functions, their derivatives also will focus, like power function, polynomials, rational functions, and all. We'll look at their properties and such details. And we also have to look at the linear and quadratic approximation. So we will start with week 5. So derivative of a function, if we take, derivative of a function if we are taking, we'll start with the basic definition of a derivative. So a function is said to have a derivative, and the derivative is equal to L at a point x is equal to x naught if this particular L is equal to f dash of x naught is equal to limit of h tends to 0 for f of x naught plus h minus f of x naught by h. So this is the value of L. And if f dash of x naught exists at a particular point, we can say that the function is differentiable at x naught. And if f dash of x naught exists for every point in x belonging to the real numbers, then we can say that the function is a differentiable function. So there is a difference between a function that is differentiable at one point and a function that is differentiable at all points. We cannot say that a differential function, if the function is being broken for functions like the mod function when you have breaks, because the function is not continuous. So continuity means it is continuous everywhere. The function is continuous everywhere. A function that is not continuous will not be differentiable. And we can also say that a differentiable function will always be continuous. Okay. So when we have to find the differential for a function where the derivative L of the function at a point, we have to take the left hand derivative and the right hand derivative. So the left hand derivative, we take it from the left side, which is limit h tends to 0. We will take it as f of x naught minus f of x naught minus h by h. The traditional function that we use to define the derivative is what we use it from the right hand side. So this is the function for the, this is the equation for the left hand derivative. And if we are looking at the right hand derivative, we can see that it is limit h tends to 0, f of x naught plus h minus f of x naught by h, which is what we discussed here initially in the definition for the derivative. So if these two are equal, we can say that the derivative exists for the function at x is equal to x naught. And we can say that the function is differentiable at that point. So we can say that the slope is equal to 0. When we say that the differential exists, we can say that there is a slope is existing. Okay. So then we are required to find the different derivative for the function at different points given x is equal to x naught. So these are the rules that we have to follow. These are the very basic rules. So first we have the addition and the subtraction rules. So if you have a function f of x and a function g of x, if you want to add them or subtract them and you want the differential of the, what the derivative of the u plus v or the u minus v, you can take it as u dash plus v dash plus or minus. So you can take the derivatives separately and add them. And if you have to take the derivative of a function like this, then you can take this, we have seen that c is a constant, you can take the c out and multiply it by the derivative of the function. Then you have the product rule, which is a very important rule. If you have to find the derivative of f into g, given that f and g are separate functions, and you have to find the derivative of the product of the two functions, you have to take it like this. You have to find the differential of, you have to find the derivative of f first and multiply it with the function g of x, and then you have to add the derivative of the function g of x and multiply it with the function f of x. So if you want to find the product, if you want to use the product rule, you have to use this equation. The derivative of f of x into g of x is given by derivative of f of x by dx into g of x plus derivative of g of x into f of x. Similarly, we also have the quotient rule, which is if you have d by dx of f by g, f of x by g of x, you have to take it separately. You have to take g of x into derivative of f of x minus derivative of g of x into f of x by g of x the whole square. So something that you have to take extreme care here is to ensure that g of x is not equal to 0, because then the denominator will become 0. So this is also a very important function, which is equation which is extremely useful. And then we have the very important composite rule or the chain rule. So chain rule simply states that if you want to take the derivative of a function which itself is comprised of another function, you have to do this in the following manner. You have to take the derivative of f of g of x first, and then after that you have to take the derivative of the inside function, which is g of x, separately and multiply those. You can use this for any number of functions. If you have, say, h of x is
Here, f of g of x should be derived by d of g of x, not d of
where
x.
where
f
I'm
of
sorry, where
d of f of gx by d of g of x.
this one, df of g of
No,
x, the
first one.
previous one,
No, ma'am. Here,
this one.
only here.
Yeah, what is now?
D of g of x. Niche.
This one.
No, no.
Which one are you talking about? This?
मैम d of f of g, d of
This
f
one.
of g of x by उसके बाद वाला.
This one, yeah.
हाँ, उसके नीचे d of g of x होगा.
Here.
हाँ. Then it is chain rule.
No, this is common for this. No, you're taking the derivative of this thing.
नो मैम, तो फिर दोनों चीज बराबर कैसे हो सकता है? आप देखिए ना, डी ऑफ एफ ऑफ जी ऑफ एक्स बाय डी ऑफ एक्स इक्वल्स टू सेम चीज इनटू डी ऑफ जी ऑफ एक्स बाय डी एक्स. हाउ?
See, this is coming like this. If you take the derivative of g of x, if you write it in this form, I think you will
मैम
get it
इट इज
clearly.
लाइक
This is
वी
what
आर
it is.
मल्टीप्लाइंग एंड डिवाइडिंग डी ऑफ जी ऑफ एक्स, सो वहाँ पे डी ऑफ जी ऑफ एक्स होगा. इसको सबसे
That
पहले हम
will
लोग
give you the same. That will give you this itself, no?
मैम हम लोग उसको डी ऑफ एक्स नहीं, डी ऑफ जी ऑफ एक्स के रिस्पेक्ट में डिफरेंशिएट करते हैं फर्स्ट में. फिर हम लोग डी ऑफ जी ऑफ एक्स को फिर एक्स के रिस्पेक्ट में डिफरेंशिएट करते हैं. तो पहले वाले में जी ऑफ एक्स आएगा नीचे में.
That is not changing. No, this is if you take an example.
Ma'am, if we do like sine of x square, we do d sine of x square dx square, then dx square dx. So that should
Okay,
be
but
g of
you need.
x.
Okay, but you need not mention that here, no. See, this is the common sign for this whole thing, this d by dx, which simply means you're taking the derivative of this. You are telling me wait. You're telling me that I need to put this here, no?
यस मैम.
Okay, okay, got it. This is how you should be doing it. F dash of g of x into g dash of x.
यस मैम. यस.
Okay, you want me to put this like this here. Okay, fine, got it.
यस.
Okay, yes. So similar to that, if you have to do for if you have to do for 3 also, you can do the same thing. Yeah. We'll have to differentiate with respect to f, and then you have to differentiate with respect to g, and then with respect to h. Sorry, in this order itself. First one you'll do f, and then h, and then g. And that order itself, if you do, you will get the solution for the composite functions. And so if we write in this manner, we can see that f dash is g of h of x into g dash of h of x into h dash of x. Sorry, I messed up the order. Give me a second. Okay, this is the order. I'm so sorry. And here also we'll get g dash of x. One thing we have to notice when we take the derivative, if we have the derivative of f of x as f dash of x, then this f dash of x can also be a function. And that function will be from the real numbers only, from real numbers to real numbers. If this f dash of x has a situation such that it also has a limit h tends to 0 for f of x plus h minus f of x by h. This is how we find the derivative of f of x. And if that exists for all x belonging to R, then we can say that the derivative of the function is also a function from R to R. For certain functions, you can see that if you take a function, for example, f of x is equal to x raised to 6 minus 4x cube, then you can see that if you take the derivative, you can get it as 6 into x raised to 5 minus 12x square. And that you can take the double derivative, and that will give you 30x raised to 4 minus 24x. And then if you go on and go on, you will get it as 120x cube minus 24. And then you will get 360x square minus 0. And that you will get a 720x. and finally you get 720, and then the last derivative, this is third derivative, this is fourth, this is fifth, and this is sixth. And if you take the seventh derivative, you will get it as 0. So you can take infinite number of derivatives for any function, and for many functions it will converge to 0 at some point, and after that it will continue to be 0. If you take the next derivative of this, it will still be 0. But for certain other functions like f of x is equal to e of x, if you take f dash of x, you will still get e of x. And however number of times you do it, you will still get e of x. Okay, and so if we can use these rules to find the derivatives for the questions which we'll face in quiz 2. But for some questions, we can also look at the question itself, and without bothering to do the use the rules, we can use the functions by looking at the functions, and we can resolve it without using the product rule or quotient rule, as these are very much time consuming. So when we have questions like say f of x into g of x, and we have to use the product rule, but if we are given that f of x is 1 by x square and g of x is equal to x square, you can see that f of x into g of x will give you 1, and the derivative of this will be 0. And if you do that using the product rule also, you'll get the same solution, because you can see that f dash of x is minus 2 by x cube, and the g dash of x will be 2x square. So if you use the product rule, you can see that it will be 1 by x square into 2x using the product rule, plus you will have minus 2 by x cube into x square. And if you do that, you can see that we will get 1 by x minus 2 by x. Where did I make a mistake? Okay, sorry, there is a 2 here. So 2 by x minus 2 by x, which is equal to 0, which is the same thing as we got here without using the product rule. And now we can take the derivatives of some specific functions. First of all, the power function. So this is a very basic rule. If you have x raised to n, the derivative will be n into x raised to n minus 1. If you have anything here, be it a fraction or a decimal, if you have a fraction here a by b, then the derivative of this with respect to x will be a by b into x raised to a by b minus 1. So this is a very basic rule, and it is a very important rule which we used in most differentiation problems. And then we can look at polynomial functions. For polynomial functions, a polynomial is any function which has a form of a plus a1x, a0 plus a1x plus a2x square plus a3x cube plus it goes on till a value n, where a and x raised to n. And if you take the derivative of that, you will get this a0 will get its derivative to 0, and then this one will become a1. This will become 2a2 into x. This will become 3a3 into x square, and the last one will become n into x raised to n minus 1. This is where this here also we can see that we are using this same identity. And then there are rational functions, which are basically polynomial functions in fractional form. And you can see that if we have a rational function p0, p1x plus p2x plus x square plus p3 x cube and so on, divided by another q0 plus q1x plus q2 x square and so on. You cannot use the rational functions, you cannot do the rational functions similar to how we get done here. Here we have to use the quotient rule. You have to ensure that q of x is not equal to 0. So we also have to look at higher order derivatives in this week's lectures, where you have a derivative for a function f of x is equal to 1 by x. If you take the higher order derivative, it is the first order derivative, v minus 1 by x square. And then if you take the second order, it will give you minus plus 2 by x cube. And so on, it will go to higher order levels. But the differentiability or even the presence of the higher order derivatives, that depends on the function. For some functions, as we saw earlier, will go off to 0. For some, it will remain the same. And for some, it will keep changing like this. And then we have to look at linear and quadratic approximations. So this is a very important theorem, the equation that you have to by heart for this. So if you take L of x, there is a certain criteria for finding L of x such that if the function f is differentiable at a given point x equal to a, and then near a we have the linear approximation, which is given by L of x is equal to f of a plus f dash of a into x minus a. Similarly, we also have for the quadratic, which is given by q of x is equal to f of a plus f dash of a into x minus a plus f double dash of a into x minus a whole square by 2 factorial. So these two functions, these two equations we have to remember, but mostly we'll have to use the linear function. So we'll use the linear approximation to do a question. This is actually a previous year question. So f of x given, some of you might have tried it, but let's just go through it. If the f of x is given as cube root of x plus 1, and you are told to find the linear approximation at x is equal to 8, or near x is equal to 8. So does anybody want to try? Okay, so we will do that. So when we are asked to find the linear approximation, first we have to ensure that we can find the derivative. So if you take the derivative of this function, you can write this as x raised to 1 by 3 plus 1. So you can use the power function. So you will get it as 1 by 3 into x raised to 1 by 3 minus 1 plus 1, which will give you 1 by 3 x raised to minus 2 by 3 plus 1. And now we have to use this equation to find the linear approximation. So if we write it here, you can see that L of x is equal to f of a plus f dash of a into x minus a. So here a is given here as 8. Sorry, a is given as 8. And if we take f of 8 from this equation, we can see that cube root of 8 plus 1. Plus, we have to take the derivative of x at a. 1 by 3 into 8 raised to minus 2 by 3 plus 1. And into that we have to subtract, we have to multiply with x minus 8. So if we do this, we can see that this is 2 plus 1 plus 8 cube 2 whole square. We have 1 by 3 into 1 by 4 plus 1 into x minus 8. So this is our function. If we can calculate that, we have 3 plus 1 by 12 plus 1 into x minus 8. So this is what you will get. But for quizzes, we have to take it to the form which is given in the options. So for this one, we had to take it to this form. We have to expand upon this. We have to put it as 3 plus 1 by 12 into x by 12 minus sorry, 1 by 12 plus 1. Okay, sorry. This plus 1 will not be there. We are taking the derivative here. No? This plus 1 will become to 0. So this plus 1 is not there. I'm so sorry. This into x minus 8. And so we have this is 3 plus 1 by 12 into x minus 8. Here 3 plus x by 12 minus 8 by 12. So if you calculate that, you will have 36 minus 8 by 12 plus x by 12. So 28 by 12 plus x by 12. And 1 by 12 is into x plus 28. So this was the form in which it was given in the options for that particular question. So we have to take care to ensure that looking at this, it might not, this is the answer we got, it might not look very similar to this, but we have to expand upon it to somehow reach the options which are given in the quest, in the quiz. That is all for week 5. So if nobody has any doubts, we can go to week 6. Shall I move forward?
Last.
Last question. Yes.
Can I see the last question again?
Oh yeah, sure. You want me to memorize it?
Can you explain this formula Lx equals to f of a plus f dash of a y?
Okay, so this is the formula that you have to understand. Very basically, you have to by heart this formula. And here, this f of a means you have the question will give you the function. So you simply have to, and you will give the question. You will be given a function, and you will be given a value of a. So for linear approximation, what you are supposed to do is you have to find the linear approximation. You have to find the approximate value of the function for a given near a given value of x, which is given by a in the question. So you are given a and you are given the function. So as per this equation, you have to substitute the value of a in the function value. Simply you have to put a or the value of a, which is 8 here, in the place of x here. So you'll have cube root of 8 plus 1. And then when you are given the function itself in the question, you have to find the derivative of the function. And that derivative into x minus a you have to multiply. So here this is different. This is f dash of x, a into x minus a. It is not like you're taking the common derivative of a into x minus a. You have to find the derivative, substitute the value of x with a, and then you have to multiply x minus a. This x we do not have to solve for. This x will be there in the question and will be there in the answer also. We are
Ma'am,
not supposed to, yeah.
Could you please explain the significance of linear approximation?
Significance of linear approximation is if you are given a function and you want to find the value of the function at 8 at a particular value a, then this is the easiest way to find the value.
Why not directly finding f of a?
That will give you errors. If we are taking a very huge number like this, we are taking a whole number, it will not be uh, so much of a problem. But even with if we use that simply, we'll get an error there. And then if we use linear approximation, even then there is chances of error, which is resolved by Taylor theorem, which we'll see later on. So since this is a number like this, that is why you are not seeing there is an issue. What is the issue with this? That is why you are feeling. But if we take it with certain numbers, this was basically all these formulas came up because it is meant to simplify calculations. We are used to, if you're told to do the same for a number like 2.187, it will be difficult. Right. It will not be evident in a function, in a basic function like this and a whole number like this. But when certain other functions come in, it will be complicated. But you don't have to worry about that for your quiz because for your quiz, basically normal functions and normal equations will be used.
Okay, ma'am.
Okay. This question is clear?
Yes, ma'am.
Okay, so we will move to week 6. So week 6 we have some very important theorems, and we have to basically the applications of derivatives. We have terms like local maxima, local minima coming in, and we have the most important mean value theorem, Rolle's theorem, L'Hopital rule, Taylor's theorem. All these are coming in. So let us start with local maxima and local minima. So one thing I forgot to mention is here you will have some very basic facts about derivatives, like a function is differentiable at x naught if this is existing. A function is differentiable function if all values it is differentiable. Such basic facts, you just have to understand it. You will not be asked to write solve equations from you'll be using this equation with the left hand derivative and right hand derivative, but these particular statements you don't have to by heart, but you may be asked these sentences as true or false statements in the quiz. So it is very necessary to have an understanding of statements like this. You will be asked if the particular function is differentiable, will it be continuous? Such statements you can be asked. So it is necessary to have a clear idea about that. And then you also have to focus on the rules like this power function rule, the chain rule, the quotient rule, product rule, all that we have to be very clear with. And then the linear and quadratic approximation rules also. That is also something which is likely to be asked as such in the quiz. And now moving on to local maxima and local minima. So the basic criteria for local maxima and local minima is that the derivative f dash of x should be 0, which simply means that the slope of the line corresponding to that function will be 0 at that point. So if we imagine that on a graph, we can see that if a function is like this, you can see that here it is the lowest point. You can also see that the slope is, it is a flat line if you draw the slope. Any point that is not the maxima or minima, like a point here, if you draw the slope, you will never get the slope as 0. But these peaks where there is a direction change. Here it is a negative peak and then there is a direction change. Here it is a positive peak and there is also a direction change. When there is a direction change, you will get the slope as 0. Those points will be local maxima and local minima. It is not necessary that it will be the biggest value that that function has, because this is also a local maxima, this is also a local maxima, and this is greater than this. But that is not our concern. We're talking about local or the maxima and minima in that particular region only. So for local maxima and local minima, the first criteria is this, and then the second criteria is f double dash of x. If f double dash of x is greater than 0, then that point is the local minimum. You just have to think that it is the opposite. If it is greater than 0, then it is the local minimum. And if f double dash of x is less than 0, then it is the local maximum. So if you are given a point on a line, if you are given a function that are asked to find the local maximum and local minimum of this, first thing you have to find is where the which all values of x, the derivative will be 0. And then there is also a condition when f dash of x is equal, f double dash of x is equal to 0. It is also a critical point, but it is called as a saddle point, and it is not required for this local maxima, local minima calculations. You can ignore that if it comes up. So if you're given a function like this and you are told to find all local maxima and local minima, you have to first find the derivative of fx and find the points at which f of x is equal to 0. So if you have points x1, x2, and x3 at which this is equal to 0, this may be more or less. If you have any n number of values for which f dash of x is equal to 0, then for these particular values, you have to take f double dash of x. Double dash of x at x is equal to x1. This is greater than 0. You can say that it is the local minimum. And if it is another one, say it is at x is equal to x2, if it is less than 0, then you can say that it is the local maximum. Okay, that is all for that. This is a very simple function. Just have to remember that f dash of x needs to be 0 initially, and then f double dash of x greater than 0 means local minima, and f double dash of x less than 0 means local maximum. And then coming to the wonderful Rolle's theorem.
Hello.
Yes.
Ma'am, actually, I joined a bit late. So, can I ask where can I see the recorded video before week 5?
It will be uploaded in the Wayanad House YouTube channel,
Wynet House
and we
YouTube
will be
channel.
and we will be sharing the links also.
Okay,
It
ma'am.
will be
Thank
there on
you.
the Wayanad House YouTube channel. You can search for that on the Wayanad House
Okay,
website.
ma'am.
There will be a link. Okay.
Okay, thank you.
You are mute.
Okay. I'm sorry. I'm sorry. So the Rolle's theorem is very much similar to mean value theorem, and we have to learn both. So these are the conditions for the Rolle's theorem. For a function f which is continuous in the interval a to b, and if the function is differentiable in the interval a to b, and it is given to you that f of a is equal to f of b, then if we can imagine that on a graph for a function which goes like this. At this point, say
Adendu, sorry to interrupted you. Basically, the video will be uploaded in the Wayanad House YouTube channel. So by tomorrow, it will be available there. Now you can continue.
okay. So if you have a function like this, and this point is a, and this point is b, this is x, this is f of x. So given that here we can see that, pardon my drawing, but here we can see that f of a and f of b are equal. So if you try to join these points, any point in between these two, there will be a point C, which will have slope as 0. If you join it like this, or if you join it like this, if you join it like this, there will be some point at least with which point we'll call it as C, which will have a slope of 0. So that is what the Rolle's theorem says. For a function which is continuous in an interval f of b, a to b, for a function which is differentiable in an interval a to b, for a function which has f of a is equal to f of b, then that function will have a point C in between the interval a to b, such that the f dash of c, the derivative of c or the slope of c, is equal to 0. This is what Rolle's theorem says. And it necessarily is not one. There can be multiple points. Like if you see these values are equal, you can join them by a straight line, means every point on the line will be having a slope of 0. So this can be one or many, but or many or even infinite, but there will surely be at least one such point. This is what the Rolle's theorem says. And now if you look at the mean value theorem, you can see that the requirements or the conditions are very much the same. You need a function which is continuous in a to b. You need a function which is differentiable in a to b. And the only difference is here we have to be very clear that f of a is equal to f of b. But here it need not be so. F of a can be equal to f of b, or f of a may not be equal to f of b. This is the only difference between mean value theorem and Rolle's theorem, and the only difference in the criteria. And here it is f of f dash of c becomes 0, but here the theorem states that there exists a point C between B and A, A and B, such that f dash of C, the derivative of C, is equal to f of B minus f of A by B minus A, which is basically the slope of the graph. As you can see here, if there is a straight line graph, and this is f of x, and this is x, for a point A here and a point B here, and this is f of B, and this is f of A, you can see that if we are taking the slope of this line at this particular point, we will take it as f of B minus f of A by B minus A. This is the how we take the slope of any function, of any graph. So that is exactly how we take it here also. If we consider a non-straight line, non-linear graph also, the same thing is applicable here also. We are taking f of B minus f of A by B minus A. So that is the, we can look at both Rolle's theorem and mean value theorem together. The prerequisites are the same. F should be continuous and differentiable A and B. F should be continuous and differentiable A and B. The difference in the criteria is that here f of A and f of B should be equal in Rolle's theorem, but in mean value theorem they may or may not be equal. And this is the this is what the theorem states. Given these conditions are satisfied, this is what the theorem states. There will exist a point C between A and B such that f dash of C is equal to 0. But mean value theorem says that as long as these conditions are satisfied, there exists a C between A and B such that f dash of C is equal to f of B minus f of A by B minus A. So here the slope is 0. Here we are calculating the slope as per the values given. Okay, so these two are two theorems that we have to understand. And now
Ma'am,
another
can
theorem
you
that
take can you take some questions on this theorem?
questions on this theorem I do not have at hand. 1 second. Okay, I'm sorry, but I do not have any questions on that. Because primarily the thing is, you will not be asked to use this to solve. You have to understand this as a theorem. And if you are required to solve it, this is how you will be required. You will be asked, most likely, you will be asked given these conditions, and you will be asked if, say, for example, you are given a question, there is a function f which is continuous and differentiable A and B, and for A and B, f of A and f of B are equal. Then which of these is correct or which of these is incorrect, and you will be given both these options. For that situation, you have to understand what is the difference between Rolle's theorem and mean value theorem. Other than
Okay.
that, the likelihood of being asked to solve numerical questions for this is not much.
Okay.
So you have to just understand the theorem and understand the difference between the two.
Okay, ma'am. Thank you.
There is another theorem for which you might be asked calculation-based numerical problems, and that is the L'Hopital theorem and the Taylor's theorem. So we can move on to that. The L'Hopital theorem or the L'Hopital rule. That is, you need not use this for every question that you encounter. This is specifically for questions which give you the indeterminate form as an answer. Form like 0 by 0 or infinity by infinity. These you cannot solve. So for such questions, we have to use the L'Hopital rule. So the L'Hopital rule states this: limit of x tends to x naught, f of x by g of x is equal to limit of x tends to x naught, f dash of x by g of x which is also equal to limit of x tends to 0 f double dash of x by g double dash of x. So basically this can be, you can go for indefinite times. You can say limit of x by x naught of f triple derivative of by g triple derivative is equal to same. You can do that how many number of times ever you want. It will help you solve it. So for this, if you take an example, you cannot understand this without an example. So basically you have to understand this. If you are given a function, if you're given a question f in the form f of x by g of x, and you substitute the given value of x naught for the function, and you get the value of x naught by g of x naught, and this gives you 0 by 0 or infinity by infinity, then you have to proceed as such. You have to find the f dash of x naught and g dash of x naught. And then if you substitute the values of x naught in the derivative function, you will get an answer. If that also you don't get, then you have to find the double derivative of the f of x and g of x and then substitute the values of x naught in that. So for that, if you like, we can take an example. This is, I think, a very common example. So if you have limit of x tends to 0 and we have x raised to 4 by 1 plus e raised to x cube. So if you take this very simply, you take the limit x tends to 0 and you try to do it with respect to simply the function. So you will try to do it simply with the function. You will get it as x tends to 0, 0. And then here also you will get it as 1 by x cube, and e raised to 0. You will get it as 1, which is okay. For this function also you can use the L'Hopital rule. Here you cannot visibly see a difference, but if you take the L'Hopital rule, you will get this as 4x cube by 1 plus, sorry, 1 is not there. You will get 3x square into e raised to x cube. So if you cancel that out, this one will become 0. And this you will get 3 into e raised to 0, which is 0 by 3 or 0 itself. So here and here you can see that it is the same. But for some questions, you will see that this value may not give you a proper answer. This part of the equation may give you 0 itself. And then, for example, if a function is given like x by x raised to 4 by x raised to 3x raised to 7 or something like that, you can see that both will give you 0. Plus 1 is there. And it will give you both will give you 0. So if you take the derivative of that, it will help you solve it easier. Okay, this one is not here. Sorry. Okay. This one, if you take, I'm not sure about this question. I just made it up now. Let's see. 4x cubed by that one also will give you the same. Let's see. This one you get the 0 by 0 form, and you take it as this form, x raised to 6 plus 1 you will get, and then you can get it as 0 by 1, which is 0. So for this one, this method was useful. So here we took the f of x naught by g of x naught directly, and we got the 0 by 0 form. And then we took the derivative of that, and then we got the 0 by 1 form, which we can say definitively that it is 0. Here, I'm sorry that example was not proper. We got right answer for both. But this is an example of where you should use the L'Hopital rule. So is that one clear? Shall we move to the Taylor theorem?
Yes, ma'am.
So before that, there is something called as monotonic functions. Again, these are not likely to be asked as calculated questions. So monotonic function is any function which follows a given pattern. It either keeps increasing or it keeps decreasing. So for a monotonic function that is increasing, for any point, given x1 is less than or equal to x2, f of x1 will also be greater than or equal to f of x2. We have some sort of a graph like this. It is always going up only. If this point is greater than this point, then f of x1 and f of x1 will always be greater than, sorry, less than f of x2. So this is greater than. And here, decreasing function of x1 is less than x2, then f of x1 will be greater than or equal to f of x2. This is monotonic decreasing, this is monotonic increasing. In this, you just have to keep in mind and remember these values, the differences. And then we have the Taylor theorem.
Ma'am, can you show that again?
1 second. Yes.
Ma'am, both are same.
Hmm?
Both are looking same.
One second.
Ma'am, in increasing, I think you have written everything.
Okay. Sorry, this one was actually this only. My bad. X1 is greater than x2. Here also x1 is greater than x2. But for this one, see, this one both will have the same pattern. If x1 is less than x2, f of x1 will also be less than f of x2. Here it is the opposite pattern. You can see here. So x1 is greater than f of x2, even though x1 is less than x2. Here it will be opposite, and here it will be same.
Yes, ma'am.
I'm sorry. And now Taylor theorem. Taylor theorem is actually very time taking. So for the quizzes, a Taylor theorem you can use it for any order of derivative, but usually we have to focus on linear and maybe quadratic. Other than that, we don't have to focus on that. There is a very standard lengthy equation for any value of n, but we have to focus on the equations for linear and quadratic. So for any one, give me a second. I'm so sorry. Okay, so this is the linear and this is the quadratic, both of which we have to focus. So for linear, we will take first. And the basic criteria for most theorems or values or equations in this is f should be continuous and differentiable in the interval a and b or a and x, whichever we are taking. So here similarly, f should be continuous in a to x, f dash should be continuous in a to x. So here only if this is differentiable, we'll get f dash, and then f double dash also should be existing in a to x. These are the criteria for Taylor's rule. So here f is continuous and differentiable, so we got f dash. F dash is continuous and should be differential, then only f double dash will exist. So given these conditions, for any value x2, for any value of x equal to x2, the theorem states that so far as x2 belongs to the interval a comma x, there will be a situation such that f of x is equal to f of a plus f dash of a into x minus a plus f double dash of x2 into x minus a square by 2 factorial. So this part we all saw earlier. It is the linear approximation. It's the linear approximation as seen here. But this is likely to have errors, and that is how the Taylor theorem was introduced. So this is exactly the same thing, L of x. And then this is the maximum possible error. So we usually take this as an absolute value. We do not care whether it is positive or negative, whether we do not have to worry about if it is L of x plus this thing or minus this thing.
Ma'am,
Yes.
what is x2 here?
X2 is any variable. X2 can be any value of x such that it is in the interval a comma x.
Can you show the application in a question or PYQ?
Yes, yes. We will do this thing first. This is the equation. So we have to by heart this equation. F of x is equal to f of a plus f dash of a into x minus a plus f double dash of x2 into x minus a whole square by 2 factorial. This equation we have to keep in mind. And we will do an example for f of x is equal to x to the power of 1 by 4. And we will be given a value of x is equal to value of a. Let us say we are given as 16. And then we are also required to find, we'll be asked like this, find the linear approximation of the function at x is equal to 16. And then we will be also asked to find, this is, as I said, this is the maximum possible error. So it can have multiple terminologies. You may be asked to find the maximum possible error for the function at a particular value x2, or you might be asked to find the bound of the error. You will be asked to find the upper bound of the error. All these can be asked. So you can be asked to find the bound of the error for equal to 8 for 8. So this error, if you are asked, here you can see this is L of x2. So this part is the error part. So if you are asked the error, you can see from this equation itself, error is equal to the f of x minus L of x. This is, you might be asked very separately what is error. So we have to understand that this function is also, this equation is also there. And for f of 16, we have to find the L of x, right? So f of 16, we have to find, we have that as 16 into 1 raised to 16 power of 1 by 4 is 2. And we have to find f double dash of x also. So which is 1 by 4 into x raised to 1 by 4 minus 1. 1 by 4 x raised to 3 by 4. So if we substitute 16 in that, f dash of x for 16, we will get 1 by 4 into 16 raised to 3 by 4, 2 cube, which is 1 by 32. So you want to find the linear approximation, which is given by this part of the equation. So we just have to add these two. L of x is equal to 2 plus 1 by 32 into x by 6 minus 16. So this part you don't have to bother about this x here. Let it be there. It will be there in the options also. It is not a concern for us. And coming to the second part of the question, and the bound of the error for it. So if we take the bound of the error, we have to understand from this equation that f of x minus Lx is equal to the error. So as I said, we are taking the absolute values. So f of x minus L of x will give you the maximum possible value such that of the error such that f double dash of u by 2 factorial, which is 2, into this thing x minus a the whole square. So this u is what sorry, I'll replace it with x2 itself. This is what I earlier wrote as x2, provided that x2 belongs to a comma x. So for that we have to find the double derivative of x, which is given by, from this derivative we can take 1 by 4 into 3 by 4 into 1 by x raised to 1 by 4. It will give us 3 by 16 x raised to 1 by 4. So here we have to understand that we have to take the maximum possible error. And we are given the value as 8. So we are told to find the bound, means we have the boundary is between 8 and the value of x, which is given earlier to us as 16. So it is between 8 and 16 for whichever value. This x2 is variable, as I said. So this x2 belongs to 8 and 16. So we have to figure out x2, which gives us the maximum value for this particular part of the equation. So in this, if you look here, x raised to 1 by 4 is coming in the denominator. In this interval, we can see that the largest number is 16, and the smallest number is 8. Here it is coming in the denominator. So as x increases, the value of f double dash of x, the value of this thing, will be decreasing because it is in the denominator. And so what value we want? We want the value of 8. So that is why in the question it is initially mentioned f of 8 minus L of 8 is what we want. So that if we take, we will get as 3 by 16 into 8 raised to 1 by 4, which is we'll have to keep it as such only. We don't have a value for this thing, no? So we'll keep it as such. So if we are asked the bound, we need to put this part also. No? This x minus a whole square is also required. This is the maximum value of f dash of x2. So if we are asked the bound, then we have to put it as such: 3 by 8, 16 into 8 raised to 1 by 4 into the value x minus, sorry, what was it? X minus a square. So you'll have 8 minus 16 whole square. Is there a difference here? Minus a whole square. Oh, okay, sorry, this 8 is not here. Put it as such. Okay. Did we miss the 2 here? And by 2 is here, no? This 2 is also here. This is 2 into. So this is the final bound that we will get. Okay.
Ayandu, I guess you are muted.
Yeah, I was asking them if they have any problem with that. If not, we can move on to week 7. So week 7. Week 7, we are moving on to a somewhat different topic. We are going on to series and sequences. We have power series, geometrical series. Then we have certain tests to consider if the series is converging or not. And then we have to talk about the convergence of series, and we will look at the radius of convergence of certain series. So we have a series sigma n is equal to 1 to infinity an. This thing converges if the limit of the n tends to infinity for the sum of the sequence is is any number, any finite number. That is the basic idea for the convergence of a series. When we talk about series, the most common series we can encounter is the JP or the geometrical series, which is we have sigma AR raised to n, which is equal to A plus AR plus AR square. Sorry. AR plus AR square plus AR cube and so on. And this R is the common ratio. So for this is the power series. Then we have the power series, which is having a format as such: sigma n is equal to 1 to infinity a raised to n x of n. This is the power series. Now, in this week's uh, classes, what we have to focus on is the convergence of sequences. And for that, we will be most likely asked whether a particular series converges or diverges. And for that, we have three tests. That is the comparison test, the power root test, and the ratio test. So the comparison test, if we go, it says that for a series an, if the series is less than another series c of n for every value of n belonging to the natural numbers, then if c of n is a converging series, then a of n will also be a converging series. If c of n converges, then a of n will also be converging. This is a very simple rule. The difficult part of the comparison test is that it is difficult to find another series c of n such that it is less than a of n at all points. And then if this one converges, then a of n will converge. And if this one diverges, then this one will also be diverging. The most simplest way, or the most simplest trick we can use with respect to the comparison test is, you can use it when it comes to questions like 1 by n square plus 1, or such questions which have a power of n in the denominator, because there is something called as the p series rule, in which any function or any sequence of the form n is equal to 1 to infinity 1 by n raised to p, if such a sequence is there, this sequence will surely converge if p is greater than 1, and it will surely diverge if p is less than or equal to 1. This is the p series rule, and with this rule, we can make the use of the comparison test easier. This rule will not be as such, but we can, if we can remember this rule, then we can be using it to find suitable cn in order to implement the comparison test. So for this particular question itself, if we take a series cn is equal to 1 by n square, we can see that this is of the form as this itself. And if we take the convergence of the series, if we take sigma n is equal to 1 to infinity 1 by n square, we can see here that p is greater than 1. P is equal to 2, which is greater than 1. So we can say that this series converges. And since our question is p 1 by n square plus 1, this, because of this one, this series will always be smaller than this series, which is what we want for the comparison test. A of n should be less than c of n. Since this 1 is here in the denominator, the whole value of a of n will always be smaller than the value of c of n. And since, as per the p series rule, this one converges, we can say that this one will also be converging. This p series rule is the most important way in which you can implement the comparison rule, because otherwise it will be difficult to use this rule. So if we are using another example, we can take another example for which this rule we can see. For in the opposite direction, you can see a situation where this diverges. So sigma n is equal to 1 to infinity, given that 1 by n square plus 2n plus 1. We need to see if this one converges. This is the question. So for that, again, we can see that if we take 1 by n square as the cn, we can see that as seen above, it will converge, and therefore an will also be converging. And if we take another example of a of n is equal to 1 by n minus 1, we take sigma 1 by n minus 1. Similarly, we can take the comparison Cn is equal to 1 by n. So here we can see 1 by n minus 1 will always be greater than 1 by n. So here this rule cannot work. That is the difference. Here we have to use the divergence rule. So the divergence rule is if there is a series d of n such that 0 less than d of n less than a of n. Here we have seen that a of n is less than c of n. And here we are seeing that if we write it in the opposite way, a n is greater than d of n. So in this situation, if we take this same example, we can see that a of n is equal to sigma n is equal to 1 to infinity 1 by n minus 1. We can take the dn as simply 1 by n. Since this is always lesser than n, this whole thing will always be greater than dn. So, and here we can see that an is greater than dn. Here, this is very obviously this thing is diverging because from the P series rule, we know that if it will diverge if p is less than or equal to 1. And here the value of n is raised, it is 1 by n, so the value of p is equal to 1. Therefore, this will diverge. And since a of n is greater than d of n for all values of n belonging to the natural numbers, we can say that this series will also be diverging. This is the comparison test, and the easiest way to use the comparison test is using the P series rule, and for that we have to remember this part. If there is a sequence of this format, then if depending on the value of p, it will converge or diverge. For the comparison test, if we are looking for convergence, we have to see that a of n is lesser than or equal to c of n. If we are looking for divergence, we need to see that a of n is greater than d of n. This is the comparison test. And then we have the root test and the ratio test, which are both very much similar. So for the root test, we have L such that this is the limit of n tends to infinity for this function a of n raised to the power of 1 by n. If this value exists, then we can use the root test. For that, the criteria is L less than 1 implies this series an will converge. L greater than 1 implies the series will diverge. And if L is equal to 1, then the test fails. We do not have to consider the situation. So this is the root test. And we have the ratio test also. So one very common situation where you will be using the root test is if there are powers of n in the question, then using the root test will be useful because we are cutting it out with this value. So the ratio test also we'll see, and then we'll look at some example. L is equal to limit of n tends to infinity a n plus 1. This is the difference between ratio test and root test. Limit n tends to infinity a of n whole raised to the power of 1 by n. All these will be equal if this particular L exists. This will be same. You can see here. This part is the same as the is very similar to the root test. These two will be equal as per the ratio test, and if such a value exists, then again this same criteria. You just have to remember this criteria. The same criteria is applicable here as if L is less than 1, it will converge. If L is greater than 1, it will diverge. And if L is equal to 1, it will fail. Same criteria we have here. So if we take an example, we we have a function. As I said, if we have powers of n in the function, say for example, we have something like 3 raised to n, then you can see here if you put it as 3 raised to n power 1 by n, we'll get simply 3. So it is very useful in such situations. And yeah, if we take an example, we can take 3 raised to n by 3 raised to n by n plus 1 whole to the power of n. So if we use this test, the root test or the ratio test, we are raising it to the power of 1 by n. We are taking the limit with the power raised to 1 by n. So if we take this, we have the limit n tends to infinity, 3 raised to n by n plus 1 whole to the power of n. 1 by n. We are taking the limit. So this will get limit n tends to infinity, 3 by n plus 1. Since the value of n tends to infinity, we can say that n plus 1 will also tend to infinity, which tells us that this whole value will be less than 1, which implies that the series is converging. This is the root test. This will be most comfortable, and this will be mostly asked also because this is the coming here for both. If you are asked such a question to find the convergence or divergence, you can use this equation and this equation, which are both similar, to find the find the value of L and compare it as per these rules to find if it is converging or diverging. So very simply, if you are given a series and you are asked if this is converging or diverging, so first you take the series, and if it is something which has this sort of a format, which has some sort of a similarity to the power p series 1 by n raised to p, which is a numerator of a constant and a power of n in the denominator, then you can use the comparison rule. But please note that the comparison rule might be difficult to use in case of other series which are not keeping to this pattern of the p series rule, because you might find it difficult to find compatible series in the exam environment. So unless it is something of this format, or unless you have very quickly getting a comparative series, it would be better to go with the uh, root test, with the ratio test first and then the root test. The root test. These are both very much similar, so you don't have to worry about that. Usually find if this is compatible with the P series rule, and you can find the solution using a comparison, using the convergence or divergence, which as per these criteria, which is one, convergence is AFN is less than Cn and divergence is AFN is greater than Cn, Dn. And then if that is not possible, then use this equation to find the value of L and then compare it with this particular criteria, which means you have to be very much thorough with this particular criteria. And then another situation another question which might come is regarding the power series. It is here. Yes, power series is something like this. So we might be asked at what value of x. This x is a variable, so we might be asked what value of x will give the function, will converge, this function will converge. Divergence is not likely to be asked. So given that this is the power series, sigma n x to the power of n, where x is a variable. And if you are asked to find the value of x such that this equation converges, this series converges, we can explain that with an example. Example of 3 into, we are taking an as 3, and we'll take the value of x's, let x is equal to 4. So 4 raised to n. So if you can look at this very simply, and you can say that m is equal to 1 to infinity. So you can say that this is not going to converge. This will go on, and the value of n will change from 1 to 2, 3, 4 infinity. And this, you can see from here that it is going to diverge. Value will keep getting bigger and bigger. But if you take a different format, you take the same one, 3 into x raised to n, and you take the value of x is equal to 1 by 3 into 1 by 3, okay, 1 by 3 raised to n, then you can see that this value will not be going up and up and up. You can see the 3 into 1 by 3 raised to 0 plus 3 into 1 by 3 raised to 1. You can, if you calculate it itself, you can see that this one will go to 3 plus 1 plus, this is 1 by 3, and then the next one, if you take it, will 1 by 9. This, as these values are becoming smaller and smaller, it will converge at some point, and so this function is a converging function. And this one, if you can see, as said earlier, 3 into 4 raised to 0 plus 3 into 4 raised to 1 plus 3 into 4 raised to 2. It will go on like 3 into 1 plus 3 into 4, 12 plus 3 into 16, 48, and so on. It is becoming bigger and bigger. That is why we said that it is diverging. But here these values are becoming smaller and smaller. Until one point we'll have a value, a very small fraction, which tells us that it is converging. So the easiest way to check the power series is depending on the value of x. If x is greater than 1, then you can say that it will be diverging. If x is less than 1, you can say that it will be converging. This is the basic funda of the power series. It will be very evident from the value of x, and if you even write a few values for n and try to add them up, you will realize that it is either it is going up or it is going down. Then there is something very important, which is the radius of convergence. So as per this, we are saying that there is a value r for a power series. In between, this is a radius that we represent it on the number line. Say we have a point, and we have a distance r to this side, and we have a distance r to this side. Within this area, the values in this part only will converge for a given particular power series. So we use the root test itself for finding the radius of convergence. The radius of convergence is usually 1 by r is equal to 1 by l. So which this l is the same as this l here. Okay. So usually this root test is used, not this one. The root test is used for the finding the radius of convergence. So for a power series, this is applicable for power series. So basically the radius of convergence is equal to 1 by L, and this gives us the range in which the value of x will belong to if the power series is converging. So for a given series a raised to n, x raised to n, radius of convergence r is equal to 1 by n, where L is equal to limit of n tends to infinity a raised to n 1 by n as per the root test as we did earlier. And this value, if we put it here, we can get the value of r. We have known that this thing should not be equal to 0, which will imply that r is equal to infinity, which is not what we want. And then that is all for the radius of convergence. Is something that you might be asked, and we need to be aware of that. And for example, if we take question infinity n is equal to 1, I think this is also a previous question, maybe, I'm not sure. N of x raised to n by 2 raised to n. If you take that, this is also of the form a raised to n to the power of x raised to n. If you can look at this, And for the root test, we require this part only. An part only we require. So if we take that here, sigma n equal to 1 to infinity, a raised to n. Whole to the power of 1 by n, if we take. For that, we need to find the limit. We need to find L first. For that, limit n tends to infinity, a raised to n 1 by n. We can see that limit n tends to infinity. A raised to n here is, you have to take this part only, because this is the x raised to n. This part we do not have to take, we have to take the a n part of it. So this is n by 2 raised to n whole raised to 1 by n. So we will get n raised to 1 by n by 2. Since n is extending to infinity, we can see that 1 by n will be 1 by infinity. So which is n to the power of 0 by 2, which is 1 by 2. So this is the value of L. And we are told to find the radius of convergence. So which will be equal to R is equal to 1 by L, implies R is equal to 2. So that is the root test. And if you so prefer, you can also do that using the ratio test. Let's see. The ratio test tells us that limit n tends to infinity for a n plus 1 by a n is equal to L. So using that, if we take this, here the a n was n by 2 raised to n. So if we take that, L is equal to limit n tends to infinity for a n plus 1 by a n. So we have n by 2 raised to n plus 1 by n by 2 raised to n. That we can take it as n plus 2 raised to n by 2 raised to n into 2 raised to n by n. You can cancel these out. We will get n plus 2 raised to n by n, which is the same as oh, I'm sorry, what did I do? This is a n plus 1. Here it is a substitute plus 1. Okay, I'm so sorry. So what will be a n plus 1? It will be n plus 1 by 2 raised to n plus 1. This is the n subscript. It is not a n plus 1. I think here also I wrote it big. Okay, yeah, here it is right. This a is bigger and this is the subscript. So here we have to take a n plus 1 value, similar to how we would take the value for any arithmetic progression. So if that we calculate, we can see limit of n tends to infinity for a n plus 1, which is n plus 1 by 2 raised to n plus 1 by n by 2 raised to n. That we can see that 2 raised to n plus 1, we can represent 2 raised to n plus 1 as 2 raised to n into 2. So if we do that, we can see limit of n tends to infinity, n plus 1 by 2 raised to n into 2 into 2 raised to n by n. This is what we get. So that if we simplify, we will get 1 plus 1 by 2. We'll get 1 by 2 into 1 plus 1 by n. This is what we will get from this thing. So we can see here that n is tending to infinity. So 1 by n will tend to 0. So here also we will get the same answer as we get 1 by 2 into 1 plus 0 into 1, which is the value of this is we can see 1 by 2. So this is equal to L. Then R is equal to 1 by L equal to 2, exactly similar to what we got as per the root test. So this is how you have to do the ratio test if required, and this is how you have to do the root test if you're required. To find the limit of a raised to n to the power of 1 by n with n tending to infinity. Please note that you have to ignore the x raised to n part of the power series and take only the a power n a n part of the power series. Here, if you have to do the ratio test, this is what you have to keep in mind. Limit of n tends to infinity, a n plus 1. You have to find the next term in the series and put it as the numerator. And you have to use the given term of the series, a n, as the denominator and find L. In both these cases, you will get 1 by L as R. So that is that. And I think that is all in week 7. Can we move to week 8? Okay, there is another point that should be noted actually. That is, we have to remember these things. It is not as a question or a calculation, but we have to remember these things about the certain functions like the log x or the e power x. So the specialty about e power x is that this function is continuous and differentiable everywhere. For almost any value. For all values, it is continuous and differentiable. And as we know, e raised to x derivative will give us e raised to x itself. And e raised to x as it tends to infinity when x tends to infinity. And e raised to x tends to 0 when x tends to minus infinity. And similarly, another thing is this: the opposite of e raised to x, you can say log x or ln x. This log x is a function that goes slowest to infinity. And this function, e of x, is the function that goes fastest to infinity than any other function. If you have x raised to 3 or x raised to 20, much more than any of these, e raised to x is a function that goes fastest to infinity. And log x is a function that goes slowest to infinity, except any positive power of x. We are not talking about negative powers, we are not talking about values x raised to minus 1 by 2. That may or may not be different from this, but with respect to any positive power of x, log x goes the slowest to infinity. So that is all in week 7. And these details are more or less data that you might be asked as statement questions, or which might help you think about certain problems in the quiz, but otherwise are not calculative or mathematical problems. So we can move on to week 8, which comprises of integration. So first off, in the integration, we are talking about the what is basically integration, which we are calculating using the area under the curve, and we are talking about the delta and the size of the interval depending upon the values a and b. And then we have the most important Riemann sums. We have left Riemann sum, right Riemann sum, mid Riemann sum, etc. Then we have the definite integral, which is a continuation of the Riemann sum concept. And then we have the integration by substitution and the integration by parts. So we can start with week 8. Okay, fine. So basically, what we all know about integration is we're talking about to find the area under such a curve, we will divide it into very small areas, and we have to find that area, and separately we can find the entire area of the curve. This is the basis for the Riemann derivation also. So we are taking very small intervals. So assuming that this part is we have to find the area, say from this part to this part. We will split this area. We have this is A and this is B. We have to find this area. This is how we can do it. We can split A to B to definite intervals, which should be very small. So how we split the interval is the size of each interval. For example, this is one interval, say delta x. Delta x will be equal to b minus a by n, where b is the b and a are the outer bounds of the area in which we want to derive, and n is the number of parts into which we are dividing the area. So that is the value, or that is the interval of that is the size of the interval into which we are splitting. So we can call this point as x2 and this point is x1, and same way we can say that x2 minus x1 is equal to delta x is equal to b minus a by n. This is the size of the interval, which is very important for calculating the Riemann sum. So we have to find left Riemann sum. We have to find the right Riemann sum, and we also have the mid Riemann sum. So very basic idea of this is we take for the left Riemann sum, we take the leftmost value of a particular interval and multiply it with the size of the interval, and we do the same for each small interval. If there are n small intervals, we do that for each small 10 intervals. For the right, we take the largest value in the interval and multiply it with the size of the interval, and do that for each interval. For the mid Riemann sum, we take the average of, for example, if it is x1 and x2, we take x1 plus x2 by 2. For this, we'll take x2. For this one, we'll take x1. And we take this value as the number for the mid Riemann sum. We take x average into the size of the interval, and we add them all up. So we have an equation for that. So left Rn, we have to take, say we are taking the interval a to b, and we have split it into many intervals x1, x2, x2, x3, x3, x4, x4, x5, etc. So this will be the first interval, a to x1, x1 to x2, x2 to x3, x3 to x4, x4 to x5, then last one will be x5 to b. This will be how it looks very practically if you look at it. So for a function f of x, if we have to find the Riemann sum, left Riemann sum, this is what we will be doing. We take the leftmost value, which is a, f of a, into the size of the interval, which is given by delta x here, into delta x plus f of x1 into delta x plus f of x2 into delta x, and so on till however number of parts we have. And then right Riemann sum is f of the last one we have to take. So here it will be x1. So f of x1 into delta x plus here will be x2, f of x2 into delta x plus f of x3 into delta x, and so on. That is how we have to take the right Riemann sum. And the mid Riemann sum we can take by taking the average. So for each one we have to take the average. For this one we are taking the average, we have a plus x1 by 2. This if we take x1 plus x2 by 2. So this is a very lengthy process. So for this we'll have to take a plus x1 by 2 into delta x plus f into x1 plus x2 by 2 into delta x plus f into x2 plus x3 by 2 into delta x, and so on. It will have to go on. So something you can notice, the left Riemann sum will be less than the mid Riemann sum, and the right it will be smaller than the right Riemann sum. So this is usually how it comes. It is not usually equal to each other. This is how the left Riemann sum will be the smallest, then the mid Riemann sum, and then the right Riemann sum. So we can use a very simple example for this also. F of x is equal to x plus 6. If we take something as simple as that, we have to find the left Riemann sum, right Riemann sum, and the mid Riemann sum. For calculating the Riemann sum, you will be told the interval, and you will also be told how many parts it has been divided into. So if you take the interval here, we can take it as 3 to 8, and we can divide it into 5 parts. So from this itself, we can take delta x, which we said was b minus a by n. So this is b, this is a, and this is n. So 8 minus 3 by 5, which will give us 1 itself. This need not be 1. Here it became 1. That's all. And for the left Riemann sum, since this is a very small value, I'll show you practically what is happening here. We are dividing it into 3 to 8 interval into 5 parts. So 3, comma 4 will be the first section. Then we have 4, comma 5. Then we have 5, comma 6, 6, comma 7, 7, comma 8. These are the 5 parts that we will get. So as we said earlier, a comma x1, this is a comma x1, this is x1 comma x2, this is x2 comma x3, this is x3 comma x4, and this is x4 comma b. So if we take that, similarly here we are taking, as per our formula, we are taking f of a into delta x plus f of x1 into delta x, and so on. So if we take it here practically, we have f of 3 into delta x is 1 plus f of 4 into delta x is 1 plus f of 5. These values we are taking into 1 plus f of 6 into 1 plus f of 7 into 1. And you have to find the value as per the function. So this is x plus 6. So f of 3 will be 9 plus 4 will be 10. 5 plus 6, 11. 6 plus 6, 12. 7 plus 6, 13. If we add that, we will get 55. Yes. And then that is how we calculate the left Riemann sum. And similarly, we have to calculate the right Riemann sum, which we have to take, as I said earlier, the last one, which is x1, x2, x3, x4, x and d. Similarly, they have to take the right Riemann sum. So for that, we will start with f of x1 into delta x plus f of x2 into delta x plus f of x3 into delta x, and so on. So here the values will be 4, f of 4 into delta x plus f of 5 into delta x plus f of 6 into delta x plus f of 7 into delta x plus f of 8 into delta x. This 8 is the value b. So delta x is 1, and our f of x is given by x plus 1. So if we take x plus 6, f of x is given by x plus 6. We take it here, we get 10 plus 5 plus 6 will give us 11 plus 12 plus 13 plus 14. If we add that, we will get get 60. And now for the mid Riemann sum, which we have to take the average. For that, we have to go here and we have to take the average for each of this. So 3 plus 4 by 2 will give us 7 by 2. This will give us 9 by 2. This will give us 5 plus 6 by 2, 11 by 2. This will give us 13 by 2. and this will give us 7 plus 8, 15 by 2. So we have to use that average value for the calculation here. So f of 7 by 2 into delta x plus f of 9 by 2 into delta x plus f of 11 by 2 into delta x plus f of 13 by 2 into delta x plus f of 15 by 2 into delta x. So each of these we have to multiply with delta x, which is equal to 1, and we have to put it into this function, which is going to be time taking. 7 plus 2, 7 by 2 plus 6 plus 9 by 2 plus 6 plus 11 by 2 plus 6 plus 13 by 2 plus 6 plus 15 by 2 plus 6. So we will get 30 plus 55 by 2 should give us 30 plus 57.5, which will give us approximately 57.5, which is what I mentioned earlier, saying that left Riemann sum is 55, mid Riemann sum is 57.5, and right Riemann sum is 60. It will follow this order. Left will be the smallest, middle Riemann sum will be the middle value, and right Riemann sum will be the largest value. You can use that if you are asked to find the three values, and you can use it to cross check. So that is all about Riemann sums. And then we have a very simple theorem which just states that the limit of Riemann is the definite integral. Riemann sum is the definite integral of the function. Just have to remember this statement. So this is like this: f of x dx is the integral, definite integral of the function f of x. And this, if you require, so you can calculate it by limit x tends to infinity Rn for the function from a to b. So this signifies that if you want the theorem explained, it is simply says that the definite integral of the function f of x can be given by the Riemann sum of the function if within the interval a to b. That is not something you will have to calculate. It is simply a theorem that you are supposed to know. And then we have the fundamental theorem of calculus. Which is given by, which tells us that f dash is the antiderivative of f. Given that f is the antiderivative of f, this is the antiderivative and this is the function. So let the function be f is equal to 3x square. Then if we take the antiderivative f, capital F, which will give us, we are basically integrating this. So this is x cube plus, it can be plus 1, it can be plus x cube plus 4, it can be x cube plus 11. This value we cannot define it, and hence we represent this by x cube plus c. So this is the antiderivative. If you take the derivative of this function, you can see any of this we take the derivative, we will get the value as 3x square. And this part, whatever the constant on this side, will go to 0. So this is what the fundamental theorem of calculus says. This value f will not be unique depending on the functions. And hence it is called as the indefinite integral. Okay, so that is there. And then you have something called as the improper integral, in which given that I is equal to s, You have week 5 to 8, no? Yes. Okay, I'm sorry. Can you share your screen and show me your dashboard for the course? Okay, okay. Is there anybody else who can just share the screen?
Yes, I will.
Just go to week 8. Okay, go to week 5, please. Just all the lectures of week 5, 6, 7, and 8. Okay, please go down. Yeah, further down. Yeah, please keep going. Yeah, week 6, can you just go a little slow? Yeah, go down. Week 7 also. Yeah, week 7 also. Okay. Okay. Yes. Okay. Yeah. Thank you. Okay. Give me one. Okay. So as per your syllabus, you would not require this last part. So we can stop it here. Actually. Uh, okay. We can stop it here. I'm sorry for that confusion. You are from ES or DS?